So you're basically going to discuss about starting with the foundations of zero trust architecture. Then we'll basically compare the legacy architecture and how zero trust can benefit you on this particular process. And then I'll walk you through a step-by-step process on how to prepare for the CCZT certificate program. Okay. And finally, I'll give you some questions to check your skills on this. Okay. That's a plan we have. Okay. So let's now begin. So let's take an example, team. Before I start the topic specifically on zero trust, okay, if you remember that there is a lot of attacks when talking about the modern infrastructure and all. You can see there is a lot of attacks which is basically happening over a period of time, right? And I'm sure that most of you have heard about that. So there's a attack which is, there is a lot of attacks which is basically, the happening in the market. Like, for example, there is something called as a SolarWinds supply chain attack has happened, right? I hope you remember
Yeah,
that. Team, please keep your mics on mute. Yeah. Okay. So what basically happens is that there is a lot of attacks which basically happen. Like if you take the example of that SolarWinds cyber attack also. So in that attack, do you know what happened? Actually, there was an attack happened to the SolarWinds platform, and basically what happened was attackers was able to compromise into their infrastructure, and what they have done is that they were able to enter the network and they were able to use a software update to do that. Like they were able to use a software update and they were able to enter the network, and once inside they were able to move laterally from one network to another. They were able to move from one system or one network to another because there is a trust on that. Okay. And because of this reach, there is a lot of lot of customers got affected, and basically a lot of issues has the lot of companies or organizations of the clients has faced the particular issues, right? So now why this happens? Okay, to give you an example, team. First of all, okay, first of all, assume that when you basically go for a zero trust methodology. Let me give an example here. Okay, uh, let's say now I have a network here. Okay, I have a complete network here, and this network, what it will do is that so when you basically want to authenticate something, for example, let's say if you want to log into a VPN or if you want to access a network, we have some perimeter or boundary based security. Okay, simple. That's a very simple word we have. We have a perimeter or a boundary based security. That means, what do you mean by that? That means the moment that I enter my credentials and I log in, that from that moment onwards, I'm completely trusted on that. Right, team? Correct me if I'm wrong. For example, let's say if you go to a cloud platform, you log into the cloud account, and once you log into the cloud account, will they ask you for credentials again if you access the service? What do you say? So I log into my, let's say I log into an Azure account or I log into an AWS account, and when I enter my credentials, do you think that they will ask me my credentials again and again? No, right? No, see, that's the reason why. The reason why it's they're not asking, because there is an implicit trust there. Okay, this person has been authenticated, and because this person has been authenticated, we don't have to worry about that because he's already authenticated. This particular flaw is what we use by many attackers now worldwide. So it's what we call as a castle and moat model. That means to enter this particular castle, you have a lot of security. You may have firewalls. You may have some like access control list. You may have a VPN. You may have a lot of security mechanisms to enter this particular security castle. And once you enter the castle, then you can access anything or anywhere, because what happens, the security is over. Like the same way, the moment that you try to access an application, or the moment that you basically try to access a cloud account, or the moment that you try to access a network, what happens is that we have a initial authentication or initial security validation process. And once that initial security validation process is over, what will happen, we no longer have any kind of a security challenge. We can directly start accessing things, changing things, modifying things as per my permission, right? And that is what been utilized by attackers for a quite long time. Like I said, to the initial SolarWinds supply chain attack, what they had done was attackers was able to compromise using a software update, and they were able to move from one network to another. They were able to compromise everything, and they were able to be there undetected for a long time, and it impacted thousands of organizations. Okay, so if this concept of zero trust has been applied there properly, the chance of this compromise is very, very less. Or even if they had this compromises, the the attackers were maybe discovered way much early, and it may not cause this much amount of challenges. Okay, so there are some principles which we have to keep in mind regarding zero trust. Okay, see, zero trust is basically where it have this some certain principles here. The first and the most important principle of zero trust is that, team, when we go for the concept of zero trust, we have a principle called as never trust and always verify. Never trust, always verify. So, as I said before, if I go for a normal model where we have a perimeter based security, where we have a security where we are basically verifying things once we enter and then we trust, those kind of castle and moat model will say. Instead of that, what we do is that there is no trust, either the person is inside or outside, there is no trust to anyone. The zero trust completely flips the perimeter model where it treats every request coming from a party as an untrusted one. I will just give an example, team. Before I discuss about the zero trust principles in detail, I'll show you a simple picture here. Okay, this may be like this is basically the whole principle of zero trust in identity perspective. But once you learn this particular principle, I can explain that particular points more easily. Assume that we have a user. Okay, we have a user who basically want to use a cloud account. Okay, maybe like he want to use a cloud application or something in Azure, assume. Okay, so what he will do is that the user may log in from any devices. The user may log in from his laptop or PC or mobile phone or iPad or anything. So in Zero Trust, it's mandatory that anyone who is logging in should use a proper multi-factor authentication. We normally, what we do is that when you implement Zero Trust, we always should have something called as a multi-factor authentication. Now, even though the user has entered the proper username or password, or even though the user has verified using a multi-factor authentication methodology, still we will verify certain criterias before we allow the access to the user. Okay, we will verify some criteria in depth before we allow the access to the user. For example, now from which location the user is accessing. For example, the user is supposed to be accessing from, let's say, one particular country, or maybe the user is supposed to be accessing from his office network. So is he accessing from the office network or any other network? Then is he using a trusted device or not? That means what, is he using his corporate laptop or any personal device or something like that? Or is the user basically trusted, or basically is the application trying to access something which he is not authorized to perform or something? What is the risk level of the user? So what do you mean by risk level of the user, team? Risk level means that, for example, there is a user who have a multiple failed login attempts. Okay, we have a user there who have a multiple failed login attempts. So if we have a user with a multiple failed login attempts, that means the user risk is considered as increased. Okay, like any exemptions are there. Like this, we will verify several access conditions based on word certain criterias, and only after the access conditions are met, the user is allowed access specifically for the service the user has requested. Right. But just in case, after logging into the cloud account, after all this headache and all the process he has done, after he has logged into the cloud account, when he tried to basically access some new service, or when he tried to access some new resource, these conditions and factors are continuously verified in the backend. Okay, now I logged into Microsoft Azure and I was able to start using that. But when I try to use something new, like maybe when I'm trying to use a security tool in my Microsoft, or maybe if I try to use the MS365, or if I try to use something else, what will happen? The user won't get any problem, but these factors will be continuously validated, or these factors will be continuously verified in the backend before allowing access to the user. That means the user has already logged in. Doesn't mean he is trusted. Before trusting the user blindly, or without completely trusting the user blindly, what we do is that the user is basically given various criterias, or we can say the user is basically having various access conditions he has to met. And only after that, the user is allowed access to any service, regardless of whether he is authenticated previously or not. But these factors will be continuously verified. Okay, this is an overview. Okay, now how do we apply this? Okay, that is what the first thing. Never trust, always verify. So in the zero trust mindset, what we do is that historically, as I said, when you basically go for a network, we first of all have authentication, then we have a implicit trust once the person is inside. I'll give you best example for this, team. When you basically go for something called as a Gmail. Okay, let's say you log into Gmail, you enter your credentials and everything. And once you log in, if you access the Google Drive or if you access the Google Keep or something like that, so if you have already logged into the Gmail, they will not ask you for any credentials there. But okay, this zero trust is completely where we don't have that level of trust. That means that we strictly follow the principle of what? We strictly follow the principle of never trust, always verify. That means that regardless of the user is basically inside or outside, no entity is trustworthy by default, regardless of the location or the identity. No one is trusted. We will verify everyone explicitly without having a blind trust on anyone. That's a point number one. Okay. The second point is that, team, as I said, instead of basically, like, for example, normally if I go for something called as a VPN, so what we basically do is that, let's assume that we have a on-premises network. Okay, we have a on-premises network. Okay, and we have a cloud account. Okay, now what we have is that the communication, if it happens through the internet, it can become a challenge, right? So what I will do is that I'll basically configure a VPN tunnel, and using that VPN tunnel, I can have a secure encrypted communication there, right? But if you go for a VPN, we have a two types. Okay, point to site VPN and site to site VPN. That means I'm connecting directly from one site to another site. That means once I authenticate using my VPN, I will be able to completely access everything in my cloud account. Correct me if I'm wrong, team. If a person is authenticating properly via the VPN, he can access the resources directly, right? But if I go for this this particular kind of a zero trust model, I don't have any access. Like, I will give him access to my network. That principle is completely removed. I will give him access specifically to only the specific application he is requesting for, not the entire network. That means he will not be able to see the number of servers, or he will not be able to see the number of networks in the backend. Instead of that, the users and devices are basically given only the necessary level of access for them to basically reach there and do their job. Okay, like that. So zero trust never give access to a complete network for a user or anyone. They basically will not give any access or anything directly to a user. Instead of that, they are given access specifically to the resources they are authorized for, like that. Okay, and as I discussed, when a user try to access, his request is continuously verified, and his credentials or parameters are verified continuously in the backend whenever he is trying to do things multiple times. Okay, it's a backend thing. Now, the whole thing is like this, team. When you basically go for zero trust, I'll tell you the reason why zero trust becomes a necessary for many organizations. If you see that modern job roles now, if you see that the latest job roles coming in the market, why zero trust is also included there, or why did the zero trust become necessary? Main I'll tell you the main reasons. First of all, nowadays people a lot of people work from home, right? Especially when this COVID pandemic came and all, there's a lot of people who work from home, and now we use cloud a lot. That means what? When we go for cloud, or when we basically access things outside the office network, that means that we have a communication or access coming through the public internet. That means we are basically not tied to the company perimeter. That's a problem. The second thing is that now attackers, what they do is that attackers basically try to enter the network, and once they are inside the network, they are already authenticated, right? Then they will be able to very easily access everything they have in the network. So those kind of things can be completely avoided when we basically go for a cloud platform. Okay, see, think like this. Normally, like, for example, let's say if let's say you go to a company where there is someone who verifies your ID, or someone who verifies your access card at the entry point. Okay, and after that, there is no verification. You can access anywhere, anytime. But if I go for zero trust, what happens? It's like wherever you go, whether it's a lobby or elevator, or or maybe your cabin door, or anywhere it is, they will basically have a separate checkpoint. That means every person will be continuously verified regardless of the identity or the device. Now, as I said before, team, see, there are some principles that zero trust actually mandates. Okay, it's not something which I say as a one single process, team. It's a These are the principles which basically they always mandate. Okay, so let me just explain that one by one. It's a quite simple thing, team. Let me explain that one by one. So when we basically go for a zero trust, the zero trust explains a word called as tenets. Okay, so what is zero trust tenets, team? So tenets means that like Let me give an example. So tenets means the fundamental guiding. The word tenets means that it's the fundamental guiding principles. So these are the core rules that guide the organizations on how they can design and operate their security systems. Okay, these are the foundation building blocks of zero trust. The first is basically what we call as a assume a hostile environment. That means that now understand or think in a perspective that all your network, all your systems, all your users, and everyone is always in an attack or risk. Okay. So in zero trust principle, what we have is that we have a panic mode. That means that we always act like everything, your network or your users or your systems and everything is under attack, or there is an attacker who is lurking around and basically messing up with you. Okay, that's a first one. Assume a hostile environment. Then the second thing is that presume breach. That means that we should have a mindset that the attackers may be already inside your company. So instead of thinking like, okay, attacks may happen, we basically have a thought process that the attackers are already inside into your network and they are there somewhere. Okay, like an advanced persistent threat. Then, as I said, no, never trust, always verify. No user or devices should be getting a automated inherent trust. Every employee or every access request will be verified. So I'll give an example, team. Now, let's say, for example, you're working in a company for last 10 years. Okay. Assume that you're working in a company for last 10 years. Though you are working in a company for last 10 years, still what we have to do? Every time you enter the security guard will verify your ID, right? Or maybe you have to swipe your card every day, right? Like the same way, similarly, apps and users has to be re-verified before accessing any resources. Okay. Then the next principle is that scrutinize explicitly. That means what? Always check for who is requesting. Point number one, always check for who is requesting, what they are requesting for, and why they are asking for it. Who is our who is asking for who is requesting the access, who what they're asking for, and why they are basically giving access. For example, let's say now, when you go to airport, what will happen? Like, even though you have a ticket, they will basically still verify your ID. They will scan your luggage and all, right? Because that's a protocol we have to follow, right? Like the same way in zero trust, access is based on strict policies. I can give you a simple example, team. Now, assume that you are trying to access your corporate network. This is your corporate laptop. Okay, assume that we have a corporate laptop. From the using this laptop, you're trying to access your corporate network. Okay, cloud network. Okay. So what this particular zero trust model will do is that first of all, they'll verify, okay, who is accessing it? Okay, it's Krish. Now, when he is trying to access what he's requesting for? Okay, he is requesting for a, let's say, access to the storage. Okay, is he authorized to perform that? Okay, then from which device he's accessing? See, I'm not just verifying the user. I'm verifying the device also. Which device he's accessing? Is he accessing from the corporate laptop or a personal device? Okay. Now I'm accessing from a corporate laptop. Okay. If he is accessing from the corporate laptop, okay, is the laptop up to date with the latest patches and updates? Is the laptop in risk? Is the laptop flagged for any lack of policies or updates? Is the laptop having the latest updates and everything installed? Do the user have any previous risk levels, higher risk levels? Is the laptop accessing from the corporate network or personal network? Like this, several factors are verified specifically or implicitly before we allow access for the user to a resource. And this verification will continue in the backend when he tried to access everything new. Okay. And based on various feedbacks like various log files, various device activity, network traffic, sim tools, various activities and all, we will basically get that analytics and feed as an input for the zero trust system. That means that now the sim tool has basically given an alert that a user has performed a malicious activity before. Assume. Okay, a sim tool has given alert about a user's malicious activity. Now what happens? That will be considered as an input for the zero trust system when the user try to access again. Okay, like that. So these are the foundation trust principles of zero trust. Now you may be thinking, Krish, do we have to basically have any new tools for this? Is this completely new? No. So these things are basically can be done with the proper and existing tools you're having, but you should basically know how to arrange it properly and explicitly like that. Now, team, So as for the zero trust, it's not like, okay, we can directly go and implement. Okay. So the zero trust is basically for this, based on this foundation pillars. That means if you want to configure the zero trust, or if you want to build a completely logical zero trust network, see, first point to keep in mind is that, team, zero trust is a security architectural framework, I can say. In a simple words, zero trust is a security thought process, a security architecture or framework. That means it is not something which is completely new. It's about organizing or doing a proper step by step effective way of doing it. It's not something which you're doing separately. That's the first thing. Okay. In zero trust, what we do is the, team, these are the pillars of zero trust. Okay. That means that when you basically go for zero trust, these are the foundation factors which we have to, means, obviously zero trust is an evolving concept where the boundaries are different, definition is different and all. But in scope, these are the factors we have to keep in mind. Or as per the Department of Defense or zero trust architecture, these are the seven pillars of the zero trust. First of all, users. Okay, so when you basically build a zero trust architecture, a user is no longer implicitly trusted on their location. Instead of that, like for example, a user accessing the cloud account from the corporate network. No, instead of that, the user's identity is just an entry point. Every access coming, a request coming from the user will be separately authenticated, authorized, and validated. Okay, because see, I can give an example. Now, whenever there is a user who is trying to access, okay, we basically has to make sure we also apply the user behavior analytics. We apply the privilege identity management like principles like that. Right. So, for example, let's say there is an employee who is working from home. Okay, we have a work from home employee attempting to access a cloud application. So, instead of verifying just a username and password, they must use the multi-factor authentication to authenticate. Then the system also will check if the device is basically company managed and compliant before granting the access. Okay. So like this, there is and for example, let's say what if the user is trying to access this data within some unregistered personal device, or what if the user is basically trying to access from a network which is completely now outside of the office network? Those kind of accesses completely denied like that. Okay, that's the first thing. The second principle is that, team, we have devices. So that means that, like the same way users, devices are also never inherently trusted. Even if they are company owned or even if they are personal, whatever it is, the devices are basically not trusted. So their security posture, their identity and compliance must be verified before allowing any access. Okay, so I'll give an example. So before granting access, the device health and compliance is checked. For example, as I said, the OS updates and patches are up to date or not. Do they have a proper antivirus or anti-malware software installed? Does that laptop have the proper firewall enabled? Does it have the proper disk encryption enabled? Is there any kind of any signs of compromise there from various other tools like that? That's what we call as a device posture. So device also is verified. It's not just a user but also the device. Okay, but let me tell you, when I discuss this, at least some people may have a thought process that, so Krish, if I go for this particular zero trust approach, does it mean that uh, we are we are basically going to face a, like a performance issue there, as these things are verified in the back end? Do we have a performance issue? To make it simple, team, if you optimally implement zero trust, it will never bring any kind of a challenge to you. Okay, to make it the easiest way, if you basically go for zero trust, the zero trust is never going to bring any challenge to you. It will basically even help you to optimize your performance as well. Okay, the third factor or the third pillar of the zero trust is basically what we call as the network or the environment. Okay, the network or the environment. So, as I said before, team, the network itself is considered untrusted. So, instead of focusing on the entry point or instead of focusing on the network perimeter, the zero trust focus on micro segmentation. Team, what does a word mean, micro segmentation? Team, anyone? That means what we do is that I want to make sure that, let's say, for example, if I have a corporate network, okay, so instead of putting all my servers in a single network, I will basically divide them into zones based on various factors. Like, for example, this is the public zone where I will basically have all my servers, which is accessible over the internet. This is a private zone. That is basically where the access should be only from the from a particular jump servers. This is the confidential zone. This is basically where the access is completely restricted for local access only. Like the same way, I divide them, right? So dividing my network into multiple sub networks or dividing my network into proper zones and ensuring that for every zone I put the proper security controls or firewalls or access control, etc., to ensure that things are completely isolated is what we call as a microsegmentation. Okay, in zero trust, microsegmentation is a very important thing because if you want to avoid this lateral movement, that means attacker enter a network segment and from there they are able to enter the other networks. That's called as a lateral movement. To avoid this lateral movement or east-west movements and all, what we do is that in every segment, in every zones, we put the proper level of security controls. We put the proper level of access control, encryption, firewall, monitoring, alerting, everything we will do to make sure that the zones are secured separately, right? And that is basically one major aspect of the thing. So dividing your network into very small isolated networks or segments in terms of application workloads, etc., this can limit lateral movements. Also we clearly make sure that what specific applications can communicate with each other. Like for example, let's say we don't want every server in the public network to be able to talk to private servers. So this particular application from this particular port number only between this particular time should be allowed access to this server. Like the same way, I can define the least privilege access. Plus, all the traffic, either the traffic is coming through the internet or the traffic is basically within the corporate network, wherever it is, all the traffic, both internal traffic or external traffic, should be encrypted. Like we have to use either SSL or TLS, IPsec, or any kind of thing. So it's very important for us to encrypt. Okay. Then, as I said, we have various things like firewalls, etc. But at the end of the day, even if you have a VPN or firewall, anything that is never considered, it's basically about which user trying to access which application with certain criteria like that. Okay. Then the next thing is that team, we have something called as a application and workload. Okay. We have something called as a application and workload. See, when you're talking about the attacks, the ultimate target of many attacks is basically the application and workloads, right? On like your containers, your serverless functions, your APIs, your websites and softwares hosted, microservice and all. So what we do is that when the request coming from to an access a network, okay, so there's no concept called as accessing a network. So what we do is that we shift the focus from securing network to securing specific application. That means that for every application, there should be a separate request you have to make. That means that each application instance or each microservice or each container needs a strong verifiable identity. That means whenever there is a user who trying to access, he is not trying to access the application network or the network, he is trying to access the application. That means the request should be separate. Each API call the user is making should be or will be considered as a separate access request requiring the validation process. Okay, like the same way we are basically having a network segmentation, we also make sure that each application component is properly divided, which should be exposed, which should not be exposed like that. Also, we have to make sure that we continuously scan the application using tools to ensure that there is no application level vulnerabilities that attackers can utilize. Okay, like that. For example, let's say previously, when you basically go for a shopping site, okay, assume that we have an e-commerce website. Okay, in the e-commerce website, previously what we consider, we say that, okay, this is the e-commerce website. Okay, but now we will not say that. In the e-commerce website or e-commerce application, I will say that this is the separate service for order processing. This is a separate service for inventory. This is separate service for payment gateway. This is separate service for order processing. Like this, we divide them into small microservices. And for each microservice, they will verify the request for authentication like that. Okay, that's how the application workload is basically there. Okay, then what we have is the team data. Data. See, ultimately, the reason why we implement zero trust or any security is what? Data which we want to protect. That is something which will help. So I want to make sure that before moving any data to the cloud platform or before putting in data in the cloud, we should clearly identify the data and categorize the data based on sensitivity, like whether it's a top secret or confidential or internal public, whatever it is, we have to make sure we are able to categorize the data based on or classify the data based on sensitivity and make sure that the proper protection is applied. For this, we use DLP tools. We want to make sure we use DLP tools there like that. Then Then we have something called as a visibility. Visibility means a view, right? So visibility means what? At the end of the day, whatever we do, the zero trust should have a proper visibility, from collecting the logs, aggregating them, managing them, getting the feedbacks from that, like this, to detect anomalies, to understand the situation. For all these things, the zero trust should have a proper mechanism to ensure that we are able to get all these things, because all the logs, like for example, the sim alerts, or from the user and behavior analytics, for threat intelligence, all this will give feedbacks to the zero trust system. And finally, all this process will be completely automated, because how much more you're able to automate this response and alerting process or integration process, that much it will be effective. Now, see, if you feel like these are completely new to you, let me give an example here. Okay, assume that I want to build a zero trust on my AWS cloud platform. Simple example. Okay, if I want to build zero trust on my AWS cloud platform, see, for the identity part, how do I secure it? I will use the AWS identity center. Okay, if I basically want to do this on AWS, okay, for securing the AWS identity, what I will do, I'll go for the AWS identity center. I will enforce MFA. I'll go for the least privilege access. If I go to Azure, I'll go show Azure AD, Azure conditional access, multi-factor authentication, PIM, etc. Then we have something called as device, right? So if for device, I will basically go for something called as a cloud workspace called as AWS workspaces, or SSM compliance manager. If I go to Azure, it's what is the name in Azure? It's called as Intune compliance. Defender for endpoint health checks are there. In AWS, we have VPC microsegmentation, private link, etc. In Azure, we have Azure firewall, Azure NSG, etc. Right? In AWS, we have Nitro enclaves or secrets manager, etc. In Azure, we have that service managed identities, like that. Like this, see, we have tools available in most of the providers. Only for those things which are not available with the provider, we have to basically go for a different provider. Okay, so to basically make all these things possible, to basically make sure that we are able to implement this level of implementation in a proper way, what we do is that is the reason why we basically go for a zero trust. Okay, and the course called as the Certificate of Competence in Zero Trust, it is designed in such a way that you will get a step-by-step idea regarding this whole process end to end. So where we have to start, so for example, starting from what is zero trust, what do you mean by a software-defined parameter, then what is the trust levels, or basically how do I basically understand the trust in zero trust, how to plan for a zero trust strategy, how to implement it, like this. We have multiple things we will learn in this particular certificate program. One benefit as a team, this is basically not a certification, it's a certificate. So because of that, you don't have to renew it again. It's a one time exam, and there is no need of renewing the exam again and again. Okay, but that becomes the benefits also, right? Because at the end of the day, people are concerned about the, whether for the examination perspective, do we have any challenge regarding the renewal and all? No, because it's a certificate program. Pointy. Now, just one more thing we'll discuss, and I'll give you some examples. Okay. So if you basically want to go for zero trust, okay, if you want to learn zero trust, I'll give you an example on how it works. This is the architectural diagram. Don't have to panic about this much. I'm giving an overview only. Okay. So if you basically want to have a zero trust team, these are the points we have to keep in mind. This may look very confusing, but don't worry. I can help you with understanding this. Okay. See, assume that we have a user. Okay, we have a user who is trying to access a enterprise resource. Okay, we have a user who is basically trying to access a resource. So who is a user? So use basically, like for example, it can be an employee or a service account. Okay, so this user is trying to access. That means he's accessing via a system, right? It can be a laptop or a smartphone, or maybe an IoT sensor, a virtual machine, a container, whatever it is. So user on this device will initiate a request to access the enterprise resource. So when the request is coming from the network, so that means any request coming from anyone will be considered untrusted. So once the user or the connection is basically trying to access a resource, he is by default untrusted. So there is an entity called as the policy enforcement point, or PEP. So what does this policy enforcement point do? This is like a gatekeeper. So whenever there is a access request coming from a resource or coming from a user, the request is basically first going to the policy enforcement point. So in the policy enforcement point is basically something which will get the request, and it is not the one who make the decision. It's like a physical security guard. Okay, it's like your body, and this is like your brain. This is your brain, and this is your body. That means what? This is the one who basically do things for you. That means allow or block whatever it is, but they just act as an intermediate. That means whenever you make a request for accessing something, your request is basically forwarded to whom? Your request is basically forwarded to the PDP, policy decision point. Okay, the whenever there's a request coming to the policy enforcement point, the request is taken to the policy decision point. Okay, so what is a policy decision point, team? Okay, the policy decision point is something basically where the one who basically makes the decision. For example, let's say whenever the user makes the request, okay, the policy engine is the one who basically applies the logic. Okay, like okay, if the user is basically a let's say a developer, or and if the system is basically compliant, then allow the access, like that. Okay, and the policy administrator is the one who will basically make the policies, like based on your inputs it will make the policy. If you basically go to the cloud perspective, okay, we have many tools for this. Like we have this AWS identity center, we have this identity aware proxy or gateway. Like this, we have different tools are there for this. Okay, and based on the feedback, the policy enforcement point will decide, okay, whether we want to allow access to or not. See, it becomes trusted now, like that. Okay, so this can be anything. This can be your microsegmentation API gateway, CASB, a cloud access security broker, access control program, or identity aware proxy, etc. Now, how does this particular control plane, or how does this particular things get inputs on if the user is safe or not? From various tools and inputs, from various mechanisms like this, they get inputs regarding whether to allow access or not. For example, let's say whether it's a CDM system. What is CDM? CDM means that continuous diagnostics and mitigation system. So whether it's coming from a CDN, or whether it's coming from a or compliance requirements, threat intel, activity logs, or maybe a data access policy, public key infrastructure, like this, they will get inputs from all these things, and these inputs are basically something which is allowed or which basically decides whether if you want to get access to something. So this is just a foundation I'm saying, team, but it's very easy to understand. This is just a very high level overview. Okay, so if you're basically planning for learning zero trust, team, as of now, currently the particular certificate things available in the market is basically what we call as a the CCZT. This is basically the one which is basically available for this particular whole process. And for the examination part, these are the domains primarily we are having. Okay, for the examination perspective, these are the domains we are having for zero trust, starting from the concepts of zero trust. What is zero trust and the concepts and all. Then we'll learn about the software defined parameter, what is an SDP, and then we'll go to the zero trust strategy, like what is the step-by-step approach we have to follow for uh, doing this zero trust and all. That's a zero trust strategy. Okay, then planning means what? So like then regarding, okay, how we are basically going to like plan as per my company requirements. Okay, that's a very important thing. Then we'll basically talk about the implementation perspective. How can I basically do it in real time? So it's a very small program, around 16 hours, but this covers the whole approach end to end. So if you're already a person who is working in cloud security, or if you're a person working as an enterprise security architect, or a cloud security manager, or a implementation strategist, or if you are an enterprise security architect, or like if you are from a security roles focusing on cloud and governance, etc., you can basically go for the CCZT. And this examination team for zero trust part, this examination is basically having like it's you have 60 questions in the exam. It's a open book multiple MCQ examination. Okay, it's an open book MCQ examination. And for this examination, the you will have around 120 minutes for this exam. And the passing score for this examination, okay, passing score for this examination is 80 percentage. And if you want to buy the examination voucher, it will cost you around 175 US dollar. Okay, the current examination cost is 175 US dollars. Okay, and you will have two attempts. Okay, That means when you basically plan for the examination, you have to buy the voucher, and once you buy the voucher, you have a two two attempts is there. That means if you miss the first attempt, you can write the exam one more time, and the voucher is valid for 2 years. Okay. You can write the exam from anywhere, from your office or home or anywhere you can write, but it's not something which you can pass just by reviewing the textbook or something. You should have a proper understanding of the concepts, because the exam is basically more of a practical thought process based. So because of that, you should have a proper understanding of the topics. And if you want to have the materials also, it's available online free of cost. But it's not just about the materials, it's about the preparation strategy. Okay, like that. Okay. Which of the following are the technical objectives of zero trust architecture? So, team, when talking about the technical objectives zero trust architecture, okay, so it's not about implementing, as I said, never VPN something. It's never about centralizing the access management something. So it's about establishing a proper framework. That's the first thing, team. Establishing a proper framework and making the user experience more simplified, plus reducing the attack surface and complexity. That's a goal of a zero trust. Okay. Okay, one more question we'll go for, team. Which of the following best describes the zero trust concept as defined by the CSA? So, the first thing is that when you basically go for zero trust, okay, the the first foundation principle is always like what? Never trust, always be. That means what? Making no assumptions about trustworthiness, regardless of the user is either inside the network or outside the network. We don't make any assumptions on trustworthiness. And starting with no entitlements, no permissions. Normally, what we do is that when a user log in, he will get a permission by default. But here, there is what happens. I will not give any permissions or anything until unless the user is verified, and even after verified, the user is basically given access directly to those things only, right? Not the entire network. The answer is A. Fine, team. So like this, team, when you basically go for zero trust, we have a lot of things which we have to understand. See, this is not, as I said, this is not only in the user level. This is the user level example of zero trust. This is the network level example of zero trust. Like the same way, we have to implement zero trust in multiple levels. Okay. And how do I do it? To implement this, we have the frameworks given by the vendor itself. For example, let's say if you want to know how to implement zero trust on Azure, so they have their own document framework for that. Like the same way, everyone, like if you basically want to go for AWS also, Azure also, for every vendors, they have their own ways for doing the zero trust implementation. See, this is the Azure website, if you can see, they have mentioned that zero trust security is there. What are the guiding principles of zero trust? And how is the architecture working? See, what is a policy enforcement point there? What is a policy decision point? Like this is the Azure architecture. Okay, like the same way. Okay, like that. So they have put a complete step-by-step document on how you can basically do it on Azure as well. But to make it simple, team, though even if I go for AWS, or even if I go for Azure, or even if I go for any cloud platform, if you feel that the provided tools are not sufficient for our requirements, if you feel like that tools doesn't give us the proper benefits as expected, in that case, what we have to do, we can basically go for a third party tools. Okay, like it's completely fine, I'm able to go for the third party tools there. Okay, like that. And this may be something which you're doing for a long time, but this establishes a proper framework on all the levels what we do. Okay, like that. And team, if you want to read more about zero trust, this is a very good link for going for this. I will share this with you. You can basically read up this more. It's a really good one. It'll give you an idea regarding the examination and all the things like that. It's not a big deal. It's quite easy, but make sure that you understand well. Okay. And feel free, if there is any queries or anything you have, you can always reach back to me on LinkedIn as well. Any queries on this, team? All good? Anyone, any queries on anyone, team? Perfect. Fine, team. So that's what I want to discuss today. Yes, we do provide training on zero trust as well. I can just share that page as well, uh, just in case if you want to see that.